And it tells us to set up and evaluate the integral that gives the volume of the solid if this region revolves around the x-axis. So you would have to use the washer method because, as you can see, the axis of rotation, there's a gap in it, so there's gonna be a hole in the disk, which would indicate to use the washer method. So volume equals pi. It's given on the graph that it intersects at 1, 1, so you just do 0 and 1. That's 0. That's easy. Remember, top function minus the bottom function. Top function squared minus the bottom function squared. So to determine if your function is on top or bottom, if you're unsure about the graph, we can check with the function. If you set x value between your bounds, and whatever y value is the greatest, you would agree it'd be on the top if the y value is greater than the other one, right? So if you plug in 0.5 or 1/2, for example, you would have y equals 1/4, and then y equals 1/2 squared, or 1/2 to the 5th would be, let's say 4 times 4 times 2, 16 times 2, 32. So the x squared is greater, which is it's gonna be on top. So it's gonna be top squared minus bottom squared dx. And evaluate the integral. So basic math, x4 minus x10, and you integrate that, you'd get x11 from 0 to 1 times pi. And FB minus FA, so if you just do that, you'd get 1/5 minus 111 minus F of A, but since it's 0, it's gonna be 0. So I'm not gonna waste my time doing that. And this would be